A pleasant day to the viewers of this video. We'll be showing to you some example problems or sample items for the new technique in integral calculus that you will learn today, which is on the substitution method. So I have here four sample problems. So let's start with item number one. So for item number one, we have the integral of 3x plus 4 with respect to x. I think there is a quantity squared. Okay, apologies. So, how do we solve this item? So you might notice na we have a difficult looking expression, which is basically this one here inside the power of 2. However, you might wonder why is there no easy looking expression that is present in the given. Take note that the easy looking expression is basically uh, the portion of the integrand that has a power less than the highest power of the difficult looking expression. In this case, the highest power is basically x. So you would expect that this x here, or x to the power of 1, has an easy looking expression with um, x raised to the power of 0. Because diba, the one that we have mentioned earlier is that the easy looking expression an exponent that is 1 minus the highest power in the difficult looking expression. So of course, 1 minus the highest power of 1, so 1 minus 1 is equal to 0, or basically x to the power of 0 is just equal to 1. So take note that there's an invisible 1 just lurking around there, either in the front or in the back, so it doesn't really matter. So I hope that you will realize in this example na if the highest power is x, then you don't really need to find if the highest power of the difficult looking expression is x, then you don't need to really find any term that contains x for the easy looking expression. So to continue, we are going to let u be equal to 3x plus 4, and then we are going to differentiate or get the derivative of u with respect to x. So 3x, the derivative of 3x is 3. So that's because there's an exponent 1 there. So 3 over 1 and then x 1 minus 1. So 1 minus 1, that's equal to 0, and x to the power of 0 is equal to 1. So you're just writing there that one as 3. Then plus 0. So you don't need to anymore write plus 0, but the answer of the derivative is equal to 3. So you multiply both sides by dx. And you will notice that du is equal to 3 dx. In your given item, you only have dx with you, but you have 3 dx here. So we can actually use this term over here to substitute the term in the integrand. So what I am going to do is to modify the equation in such a way that I can replace the dx here in the given integrand. So to do that, what I'm going to do is I will divide both sides by 3 and then obtain the value of dx. So you have du over 3 equals dx. So now I have two equations that I can substitute in replacement of the contents in the integral. So I have u equals 3x plus 4, and I have du over 3 equals dx. Okay, so once I have that one, I can substitute. I'll just place that one here to conserve space. Therefore, you have the integral of 3x plus 4, you change it with u to the power of 2, and then your dx, your dx means du over 3. So that is du over 3. So further simplification, we have 1/3 u to the power of 2 with respect to u. So let's continue the entire process using power rule, basic integral or basic integration rules. So bring out the the 1/3 outside, the integral sign. You have u squared with respect to u, and then you apply the power rule. So what is power rule? If you recall, you have u to the power of 3 over 3 and then plus c. Okay, and then afterwards, you have 1 over 9 as your coefficient. You have u to the power of 3 and then plus c. Okay, so we're not done yet. So what we're going to do is to recall. So recall that u is equal to 3x plus 4. So you have 3x plus 4. And therefore, your final answer will become equals 1 over 9, 3x plus 4 to the power of 3 plus c. Because at this point, you are reverting back the u into its original form containing the x variables. So your final answer is this one. Okay, so that's it for item number 1. Okay, so let's go to item number 2. I will just copy this one here. So for item number 2, we have to evaluate the integral of x squared minus 1 quantity, or x squared minus 1 to the power of 4 multiplied to x with respect to x. So of course, the first thing is to let u be equal to, of course, by now, I hope you know what is the difficult looking expression. It is the x squared minus 1 because it has the highest power and it's usually enclosed in a power or in an exponent. And what we're going to do next is to do the derivative. The derivative of u is equal to, derivative of u with respect to x is equal to 2x minus 0. So you don't need to write the 0 there. Multiply both sides by dx. Cancel, cancel. So you have du is equal to 2x dx. So I think you are familiar, or the term x dx is present on both the equation here on the right and a particular term in the integral. So what you do to force the equation on the right to be fitted or to be substituted to the integral sign is that we are going to manipulate the equation on the right in such a way that the right side becomes x dx. So to do that, what I'm going to do is to divide both sides by 2. So after dividing both sides by 2, I have du over 2 is equal to x dx. So I can substitute the du over 2 And I can substitute the u equals x squared minus 1 in the integral. So to do that, so we have therefore substitute, we have x squared minus 1, that becomes u to the power of 4, and then x dx is du over 2. So I hope you were able to um, spot or trace how the substitution was done. And then I will rearrange the entire thing in such a way that I will write the 1/2 first, followed by u to the power of 4, and then write du. So you then apply the basic power rule, basic integration. So you bring out the exponent, the coefficient rather, integral of u to the power of 4 du, and then we have what's next? 1/2 u to the power of 5 over 5, and then plus c. So after which we have 1 over 10 u to the power of 5 plus c. So we're not done. We need to recall the meaning of u. Recall that u is equal to x squared minus 1. So x squared minus 1. And then substituting, we have 1 minus 10 x squared. Okay, class, sorry, no? Sorry for the cough. X squared minus 1 to the power of 5 plus c. So that will be your final answer for this item. Okay. Okay, the third item. Okay, what is the third item here? Oops. Okay, the third item is this. So I think we have discussed this one. I don't know if I have discussed this one in my other class, but I think it's easy to spot the difficult looking expression. So the one that we are going to let you here should be x squared plus 2x plus 1, and then um, we are going to get the derivative with respect to x. So this becomes 2x plus 2 plus 0. So no need to write the 0. We're going to multiply both sides by dx. So remember that when you multiply this one, the right side contains two terms. So you have to be careful in multiplying it. You should not multiply it to one term already, so to just one term. So make sure that you put a parenthesis, okay, to group the entire or the two terms in the derivative. Okay, you might notice that we have here 2x plus 2, but what is found here in the easy looking expression in the integrand is x plus 1. So of course, if you have your mathematical intuition with you, you will think that, oh, 2x plus 2 is just x plus 1, you multiply it by 2. So what you can do here in the du equals 2x plus 2 dx, you're just going to extract out the 2 because 2x and 2, the common terms for the two terms are 2. So you can just get the 2 out from each of the terms and uh, condense it into x plus 1. And then dx. So I hope the viewers of this video um, find the process okay, or valid, so you don't get confused how I do it, no? So I'm just extracting the 2. Okay, common term man siya for each of the terms. It's common for both 2x and 2. So it's valid to do that. And for me to get x plus 1 dx, same as the one here in the integral sign, uh, kanang, what you will do here is that, what I will do here is that I will divide both sides by 2, and then I will get x plus 1 dx, times dx. So same na siya sa makita ninyo here sa integral sign. Okay? So we can now substitute the following. We have u equals x squared plus 2x plus 1. And then we have du over 2 equals x plus 1 times dx. Okay? So let's substitute. So we have the integral of, so x plus 1 dx is equal to du over 2. So that's what you're going to write here. Du over 2. And then over cube root of x squared plus 2x plus 1. So you will just write there cube root of u. Okay? So it's now simplified. So to do that, of course, you need to simplify a lot, no? So this becomes, the du over 2 is just like writing 1/2. Or you can just, it's just 1/2, no? And then you can just bring that as a coefficient. And then this becomes times du over square root of u. A cube root of u. So again, the cube root of u is not useful. So we can convert that one to integral of 1/2 times du over, not x, u to the power of 1/3. Okay? But again, this is in the denominator, so we cannot do the power rule right away. So we are going to modify it. It becomes 1/2 u to the power of negative 1/3 du. So I hope you don't find it difficult already at this point as to how I did this. So gi-reciprocator na ko siya. I reciprocated it, and then it became this way. Okay, you apply the power rule. You bring out the 1/2 integral of u to the power of 1/3 du. So this becomes 1/2 u negative 1/3 plus 1. Oh, this is a little bit tricky. So I'll just write it here. So even me, I get a little bit confused with the adding of fractions. So you have to also be careful. Okay, so I'm correct. 1/2, you have 2 u to the power of 2/3, and then over 2/3 plus c. And after that, you get 1/2 times, the reciprocal of 1 over 2/3 is 3/2. And then u to the power of 2/3 plus c. So, finalizing, we have 1/2 times 3/2, that's 3 over 4 u to the power of 2/3 plus c. And then recall that the meaning of your u is equal to x squared plus 2x plus 1. So we have x squared plus 2x plus 1. So you have 3 over 4 x squared plus 2x plus 1 to the power of 2/3 plus c. Okay, so that's it for item number 3. Okay. For the last item, number 4, so I'll just copy it. Okay, this will be our last item for the sample problems. For item number 4, we have let u is equal to the difficult looking expression is the highest power. And then, if you're going to differentiate this, this becomes du over dx, that's equal to 3x squared plus 2. Okay. And then multiply both sides by dx. So cancel, cancel. We have du equals, again, make sure to write parentheses to avoid confusion. Okay. So now, what happens here is we have 3x squared plus 2. But what we have here in the easy looking expression is 6x squared plus 4. So if you have the mathematical intuition already, you will notice na, 3x plus 2, when I multiply it by uh, 2 instead, I will get 6x squared plus 4. Right? So what you can do here is you can actually force the equation to have a value of 2 for both sides. So what I will do here, since I want my du or this term here to contain 6x squared plus 4 because I will substitute it here as what I did in the other items. What I can do is I will multiply both sides by by positive 2. So of course, what I do on the left, I do on the right. So if I multiply both sides by 2, this is what will happen. 2 du is equal to 2 times 3x squared plus 2 dx. And then I can distribute the 2 on the two terms. So this becomes 2 du is equal to 6x squared plus 4, and then dx. So you might ask me, sir, is that valid? Are you not changing the equation actually? You are forcing something that should have not been there? The answer is it's valid because I am not, or I am actually following the, or I am actually preserving the meaning of the equation. Because the meaning of an equation is what I have on the left I should also do on the right. So I'm just doing it. I'm forcing a value to be added in the equation, but what I did or the addition or the multiplication that I did rather for both sides is valid since the multiplication that I did for both sides is equal. So I think one thing that you have to learn from this example is you have to really imagine or have that intuition in your head that, what should I do or what basic mathematical operation should I do to modify the du over dx equation in such a way that I can easily substitute it in the integral that I have. So this is my way. So I think it's the only way to do it. So to force, I forced the 2 on both sides to force the right side to become 6x squared plus 4. And then right after, the 2 du is of course something that I will substitute rather in the equation later. In the integral rather later. So yeah, so that's it. So I hope you were able to um, get the idea behind it. So let's continue. So we have the integral of x cubed plus 2x and then u to the 5 because there is a power of 5. And then 6x plus 4 dx, the meaning of that one is equal to 2 du. So times 2 du, and we have integral of 2 u to the power of 5 du, and then equals 2 integral of u to the 5 du. So you will apply power rule to u to the 6 over 6 plus c So we have 2 over 6 u to the power of 6 plus c. So 2 over 6 in lowest terms in mathematics, we can simplify it as 1 over 3 u to the power of 6 plus c. So the final answer is, okay, recall that the meaning of u is the meaning of u is x to the power of 3 plus 2x. So x cubed plus 2x. So substitute x cubed plus 2x to the power of 6 plus c. Alright. So that will be all for my sample problems. I hope you learned something today and see you in my next videos related to integral calculus.